In this video, we're going to be drawing some external threads. Open up your set inch template and save it as external thread tutorial. All right, so we're going to draw a shaft that has threads on both ends. One end will have a coarse thread and the other end will have a fine thread. And we're also going to dimension those threads. All right, so let's start out by drawing the shaft. And it's going to be, well, let's switch to the visible layer. It's going to be a 1/2 inch diameter shaft. So we'll just draw a rectangle. Dimensions, it's going to be 6 inches long and 0.5 high. All right, so there's our shaft. And let's draw the circular end of the shaft, and we're going to extend from that. Let's get out of that. I need to get my midpoint selected. Get back into the circle, and let's extend a line from that, and then diameter 0.5. All right, so let's add our center lines. Change to the center layer. All right, I'm going to change the dashed. Make it a little bigger. I don't know why, but they tend to have it half the size it should be. There we go. All right, so there's our shaft and our circular view. So now we are going to add the right end of our threads. So I'm going to explode this rectangle because I'm going to need the end piece. So I'm going to explode it, and then I'm going to copy the right end by 2 inches to the left. So relative to angle 180, and that's going to give me the limits of my threads. So the threads are 2 inches on the right side. And then on the left side, they're 3 inches. So I'm going to copy that. So copy this one, relative 3, angle 0. Oh, that did my base point. So I'm just going to put it in again, relative 3, angle 0. And there we go. So we have defined our area for the threads on the right and the left. All right, so the threads on the right are 1/2 13 UNC, and the threads on the left are 1/2 20 UNF. So you can go into the tables and look up the size of the minor diameter for both of them, and then draw what is the actual dimension. So let's go ahead and do that. If you go into the tables, you'll notice that there's a formula to calculate the minor diameter. So let me type that out. So the minor diameter is equal to the major diameter minus 1.0825 times the pitch. All right, so let's do that for the course threads. So we have the minor diameter for the UNC equals the major diameter, which is 0.5, minus 1.0825 divided by 13, because the pitch is 1/13, because the UNC is 1/2 13. So that's going to be 0.417. And for the fine threads, so UNF is over 20. And that's going to be 0.446. All right, so now we have the minor diameter calculated, and we can start drawing. All right, so we're going to use the offset command and create the minor diameter. So we're going to offset the outside edges of the cylinder. So we're going to take the coarse one first. So we're going to take the major diameter, subtract this, and divide it by 2. So 0.5 minus 0.417 divided by 2, and we get, so offset command, we're going to offset through a distance of 0.0415, and offset this in, offset this in. All right, so now we just need to trim that off, this one off, and delete this and this, and then change those two lines to the hidden layer. Hit the escape key. All right, so that is for the coarse threads, and now we need to do that same thing for the fine thread. So we're going to offset, and this time major diameter 0.5 minus 0.446 divided by 2, 0.027. Trim, delete, and change them to hidden. All right, so you can see for the fine thread, the depth of thread is much smaller, right? That's because they're fine thread, you would expect that. Now, if you come upon a fine thread where the distance between the minor diameter or the root and the crest is so small that it kind of interferes with the reading of the drawing, you can make that distance 75%, the minor diameter 75% of the major diameter. That's fine. All right, so next we're going to put the chamfers on. So we're going to put the chamfer on, and the chamfer is going to be the size of the distance between the root and the crest, so the thread depth. All right, so for the fine thread, 0.027 or 0.3, let's just make it 0.03, and we will take off the snap. And this line, oh, don't want to do that line. Let's try that again. This to here. Repeat the command. All right, and the other side. So chamfer distance 0.04. This side, that side, and then get into the visible layer and connect up the lines. Put the snap back on. All right, so we have our shaft with the threads on both ends, and now we need to draw our circle here. So I'm going to put a line temporarily from this chamfer so I can add my circle that indicates the chamfer, and then just delete that line. All right, and we can add our dimensions. Now you're probably wondering why I'm not using datum dimensioning. Right, I'm dimensioning the thread length instead of coming from the datum over here and dimensioning here. Well, because I'm assuming that the thread length is more important in this case, so that's why I am taking this 2 and choosing not to come from the datum. All right. All right, so let's move this. Well, we can get rid of the text. And let's put our thread dimensions in. So multi-leader, we'll just do nearest. And we have 1/2. This is a rare occasion, and undo that, we don't want them stacked, where you are going to use a fraction on your drawing. So 20 UNC, or sorry, UNF. And the other side. So 1/2, undo that. UNC, sorry, 13 UNC, and there we go. So now we have our threads completely dimensioned and our thread notes, and there you go. This is the simplified version, right, because it's very easy to draw. So go ahead and save your drawing.